So we're back. This is All This Math, and I am Professor Parker, and we're doing some more Eureka Math. So for this lesson, this is lesson 27 from Module 5 from grade 3. All right. So I took a couple of problems from the problem set in the workbook that we could talk about. These problems aren't too difficult, but as with anything, if it's not explained to you and you don't, it's not explained to you in a certain way, it still will be difficult. So I'm gonna try to explain it, try to break it down in a way that you might understand differently or better if you don't already understand it. So let me read number 3. Number 3 says, why are 6 copies of 1/8, the fraction 1/8, equal to 3 copies of 1/4? And to draw a model. So what I have right here is I already have 2 fraction bars, right? To do a problem like this, you want to draw 2 fraction bars, but you got to make sure that your fraction bars are the same exact size. This won't work if your fraction bars are not the same exact size. You can't have one fraction bar be this big and the other one be this big. It's not going to work. Your fraction bars must be the same exact size in order to do this. All right. And with a lot of the work that involves comparing fraction bars, your fraction bars must be the same exact size. So that way, when you partition them or cut them up into smaller pieces, the same way you cut up a cake, right? You would be able to see what fractions are equal to other fractions. But it starts with the larger rectangle or the fraction bars being the same size. And these are roughly the same size. Even down here in number 4, these are the same size. All right. So now, how would you know if 6 copies of 1/8 are equal to 3 copies of 1/4? Let's draw them and see what happens. All right. So let's take the blue marker. All right. So 6 copies of 1/8. So that means I'm going to use this fraction bar. I'm going to partition it or cut it up into pieces, each of them being 1/8. So I'm going to cut this up into eighths. Now, the way I like to do it is, because 8 is an even number, I first cut the fraction bar in half. So I find what I think is the halfway mark, which is about right there. And that's half, right? So now I got 2 halves, but I'm trying to cut it into eighths. So I got to keep going. So then each of the halves, I cut them into a half, and that creates fourths. So I find halfway over here, and I do that. And I find halfway over here, and I do that. Now I got fourths. I got 1, 2, 3, 4. Now I got fourths, but I'm trying to get the eighths. An eighth is half of a fourth. So to get the eighths, I got to take each of these fourths and cut them in half. I got to partition them into halves. So then I'm going to have this, and then this, and then this, and then this. And now I got eighths. 1, 2, 3, 4, 5, 6, 7, 8. Each of those little pieces is 1/8. And all 8 of them together is the entire fraction bar, or the whole. All right? But we're going to add, so first we had to do eighths. Right? So we did that part. Now in the other fraction bar, because we want to know if this 6 copies of 1/8 is equal to 3 copies of 1/4. All right. We got to cut this one up or partition this one into fourths. So first we do half of it. Right? That's halves. But we need fourths. Right? That says 1/4. Just like we needed eighths. We got eighths up here. We're going to have fourths down here. Now that's half. And then we take half of each of those to get the fourths. Right? So we got 1/4, 1/4, 1/4, 1/4. All right, now go back to the question. Why are 6 copies of 1/8 equal to 3 copies of 1/4? Draw a model. So let's draw 6 copies of 1/8. Let's shade those in. Let's shade in 6 copies of 1/8. So here's 1/8. Here's 2/8. Here's 3/8. This is the fun part. I like this part. We just get to draw. 4/8. 5/8. 6/8. Right? So that's 6 copies of 1/8. Right? 6 of them. 1, 2, 3, 4, 5, 6. 6 copies of 1/8. Now, if we draw also 3 copies of 1/4, we want to see if those are equal. If they're equal, that means they're going to look the same size. They're going to be just as big. All right. So 3 copies of 1/4. So here's 1/4. Here's 2/4. And here's 3/4. Now, is this amount in this fraction bar just as big as this amount in this fraction bar? When you look at it, it looks like it is. They look the same size. They're equally as wide. First off, and this is why it's so important, like I said in the beginning, the two fraction bars have to be the same size in terms of the whole thing. They got to be the same size. They got to be equally as wide, right? Or else you can't compare them. You can't compare two things that are not of the same units, so to speak, or of the same dimensions, so to speak, right? So 6 of these eighths is up here. 3 of these fourths is down here. Now, this is just as big as this. Think about like a sandwich or a sub or something, right? A hoagie, or depending upon what part of the country, whatever you might call it, right? If this is the whole sandwich and this is a whole sandwich, but this one is cut into 8 pieces and there's 6 of them, right? 6 of them get eaten. This one is cut into 4 pieces and 3 of them get eaten. From how it looks, you could tell the same amount of sandwich got eaten from each sandwich, right? Even though this sandwich is cut into smaller pieces and this sandwich is cut into bigger pieces, the same amount of sandwich altogether got eaten. All right? So that's what we do for number 3. All right? Now, let's look at number 4. Number 4 says, it's very similar to number 3. It says when the holes are the same, let me underline that, that's important, the same, how many sixths, let's underline that, that's important, are equal to 1/3? How many sixths are equal to 1/3? How many sixths are equal to 1/3? So because we're dealing with 6, we're going to put 6 in this fraction bar. And then we're going to put thirds in this fraction bar. And we're going to see how many sixths are equivalent to 1/3. All right, so first we're going to draw a 6. Now, because 6 is an even number, we're going to first cut this fraction bar in half. All right, so I'm going to do this. Boom. I cut it in half, so now I got halves. But I need 6 altogether. So I'm going to need 3 on this side and 3 on this side. 3 on this side and 3 on this side. So I'm kind of going to try to eyeball it. Boom. That's 1, 2, 3. And then over here, I'm going to do the same thing. Try to eyeball it. 1, 2, 3. So now I got 6. I got my sixths. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Each of these little blocks is a sixth. Each of these pieces is a sixth because this fraction bar is partitioned into sixths. Then in this fraction bar, I want to partition this into thirds. So because that's an odd number, I kind of got to eyeball it. And that looks about right, approximately, right? Now, when the holes are the same, how many sixths are equal to 1/3? So first, let me draw 1/3. Let me draw 1/3, right? If I draw 1/3, I go like this. I shade in 1 of them. I don't shade in 2 of them because 2 of them would be 2/3. I don't shade in 3 of them because 3 of them would be 3/3, or the whole thing. Because remember, whenever you have a fraction and your numerator and denominator are the same number, that fraction is equal to 1. Remember that. All right, so that's 1/3. Now, how many, underline that, those words are important. How many sixths are equal to 1/3? So look at where it lines up. How many of these up here are the same size as this piece down here? I would say 2. Because look how it lines up. 2 of these is the same size as 1 of these. 2 sixths is equivalent to 1/3. And this is our model. This is what our model looks like, which proves that. So to answer the question, when the holes are the same, how many sixths are equals for 1/3? The answer to the question is when the holes are the same, 2 sixths are equal to 1/3. All right? And that's one of the examples. That's 2 of the examples from lesson 27. All right? I hope that makes sense to you. If it still doesn't make sense, which is quite fine, that happens. You might just need to, see it again or think about it some more. Rewind the video, run it back, and, think about it some more, All right. But I hope it did make some sense to you, and I hope it helps you in your work in the Eureka Math curriculum. Until the next video, peace.